Well, here we go again, guys. The last one, the second derivative test. I'm going to go through it along with the first derivative test with you one more time. All right, so let's start with an example. Now, you've seen this example before, but we're going to look at it again. Y equals 1/3 x cubed minus 9x. And what we're going to do is not only determine the relative maximums and minimums and intervals of increasing and decreasing, but we're also going to determine the points of inflection and concavity of this thing. So here we go. The first thing, of course, we're going to do is the first derivative test, because we need that. I don't know what's going on. Let me fix this. Okay, because we definitely need that to be able to get to the second derivative test. So dy dx equals, what is that, x squared minus 9. And of course the roots of this are x plus 3. Well, let's just look at it this way. We know what the roots of this are. The critical points are x equals plus or minus 3. If we put these on the first derivative number line, alright, and we test our values. We have 0, we know this is negative, positive, and positive. Okay, so this is going to tell us that we have a maximum here again, and a minimum here. So we need to label those. Okay. And we know, and we can also state, it's increasing again from negative infinity to negative 3, and from 3 to infinity. But we know it's also decreasing from negative 3 to 3. Okay, well that's all well and good. We've known that, we know how to do that now. But now what we need to know how to do is we need to know how to do the second derivative test. I want to move these up out of the way. The second derivative test tells us points of inflection and the concavity. In other words, where it's opening up and where it's opening down. So the second derivative test implies, well, I need a second derivative. So that's what I'm going to do. So y double prime, in this case, is just equal simply to 2x. And just like the first derivative, we set it equal to 0 and find where it's equal to 0. This is possibly a point of inflection. And I say that it is possibly that. You have to make sure there's a change in concavity for that to occur. So you do just like you did with the first derivative, you put it on a number line. This time label it as a second derivative and put your point on. So we pick a point here like 1, okay? We know that's positive, and negative 1 would be negative. So yes, there is a change in concavity because these, this time, indicate concavities instead of increasing, decreasing. So what this also means is something else. This is definitely a point of inflection because of this change. But we also now can determine where the graph is concave up. Well, let me write it out for us this time. I refer to it as cup. Okay? Concave up. That means it's opening like this. Okay? And that would be where the second derivative, where the second derivative is positive. So that would be from 0 to infinity. Now notice on the 0 this time I'm putting in a parentheses and not a bracket. For these, they're very picky about them. It does not include the point of inflection. Concavity is a shape, not a it's a shape, not a value. Okay, so you need to make sure when you do this that you put that. And then of course it's going to be concave down from negative infinity to 0. Once again, putting the parentheses instead of the bracket. Okay, and there you have it. So let's do one more. and then I'll let you guys get to your work. Let's see. Let's do. Let's try this one. Okay, we're going to go with this one. So of course we take the derivative, y prime. And what we're going to do this time is jump right to the second derivative and take care of that just because of time. So that's 3x squared minus 12x. And of course we take the derivative again, and that gives me 6x minus 12 for my second derivative. So that's equal to 0. And that, therefore, my inflection point would be x equals 2. Possible inflection point, I apologize. So we do our second derivative number line, labeling carefully. Okay, and we have the 2 here. And so we do a little test. We take 0 and plug it in. Obviously, if I plug 0 in here, I am negative. Okay, and if I plug 3 in here, I am positive. So that tells me I'm concave up from 2 to infinity, and concave down from negative infinity to 2. All right?